Okay, good morning. So, the last couple of classes we talked about inheritance, and we also talked about overriding, and we also talked about the abstraction piece of it. Abstract classes, abstract methods, the fact that abstract classes cannot be instantiated, etc. So now, when I talked about abstract, I said that at the time of design of the classes, you know for a fact that a certain behavior exists in the superclass, but you don't know how part of it. Meaning you don't know the implementation of it, but you know that every animal has to be able to eat. So that is why we made that eat as abstract, because every animal eats differently. So if 90% of the animals eat same way, then we can go ahead and provide the implementation in the superclass so that 90% of the subclasses will automatically get that functionality, and the remaining 10% of the people who eat differently can override it. But if at all 90% of the animals eat differently, then there is no point in providing functionality at all in superclass. Then we make that method as abstract, meaning I don't know how part of it, I don't know how animals eat, but we know that animals eat, and this is the method name, and these are the inputs, these are the outputs. We say that, and we make that method as abstract. And obviously when a method is abstract, we have to declare the class as abstract, and abstract classes cannot be instantiated. So what caller has to do is he has to extend this abstract class and provide the implementation for the abstract methods, and then he can start using it. Like he will provide the implementation for the eat method, like how that particular animal, whatever it is, dog, cat, etc. So that is abstraction. And even though we have this abstraction, we are saying that eat is abstract because every animal, at least 90% of the animals eat at least 90% of the animals eat differently. So we made it abstract. We are not going to provide any implementation at all. But let's say walk. Percent of the animals walk similarly, so we provide the actual implementation in the superclass itself. So this is called, I'll call it concrete methods. Concrete methods. When I say concrete methods, methods with method body, with the curly braces and providing the method body. So I'm providing how they walk also here. But here I'm not providing how. I'm just providing just method signature and a semicolon. Right? So in abstract class, you can have both abstract methods and non-abstract methods. Non-abstract methods, I'm calling it from here onwards concrete methods. Concrete methods is nothing but method with the implementation. Abstract methods are the methods with just method signature, no implementation. So abstract class can contain both of them. But now how about this? So what does these abstract methods provide? Well, abstract methods provide API application programming interface to your clients, meaning your clients know that animals eat, okay, and they can safely do this way. Animal A equal to new dog. Since dog extends animal and there is an abstract method called eat, dog must have implemented that eat method, and I can safely go and call that method. I can safely assume that eat has already been implemented in dog. Because this is abstract here, since dog extends animal, dog must implement that. So the beauty with abstraction is that it is providing a way to interact with these animals. So see that? I have this eat method. Let's say I'm not creating dog. I'm creating a different animal. Let's say I'm creating a cat object. Okay? But still, my code works. I don't have to make any changes here because I know this eat method is there in animal. Since cat extends animal, cat must have implemented that eat method too. Cat must have implemented the eat method too, because I know eat exists in animal. So polymorphically, this will call cat's eat method. Let's say I want to change my dog, cat, and now I want to change to cow. I don't have to change anything. So what am I achieving here? I don't have to change the code if I code to the super type. Right? So you may be wondering, what are we really achieving this abstraction? Well, what we are achieving with the abstraction is this one. Is this the confidence that I'm coding to the top level class, so at runtime, the appropriate subtypes method will be called. And I don't have to, even though my actual type is changed, I don't have to make any code changes. So what it is providing me is an API. If at all we don't follow this abstraction, what happens is your cow says that rather than eat method, cow says that feed. Then dog says what do we call, dog eat dog or something like that. There is a different method. And then cat will say that drink. Okay. I'm assuming here that the functionality is exactly same, but they have provided their own method names. They have provided their own method names. If they have their own method names, okay, my code today, if I say that cow C equal to new cow, okay, C dot feed. So if I change my animal, then I need to make make the code changes because they are not providing one seamless interface to deal with. Are you getting it? It's really beautiful concept. That is why rather than giving chance to the subclasses, what you do is in your top class, hey, we know that every animal has to eat. I don't want these animals to provide their own methods for eating. Rather, I will provide the method name. I will provide the method name and they will implement it so that the caller will get the polymorphism. Caller can safely do an animal.eat. But what happens behind the scenes is the appropriate subtypes eat method will be called. So we are getting uniform API across all the subtypes. We know for fact that it doesn't matter what animal it is, every animal has eat method. We know that for confidence. So that is what is API. It doesn't matter what animal it is because animal itself has that method. So even though we don't provide any method implementation, that is the beauty with abstraction. We know that it has eat method. And you provide me appropriate subtype, I'll call it. Because I'm coding to supertype. I'm coding to supertype. Now we talked about the fact that the abstract classes can contain both abstract and then concrete. Hey, what about this? What if you don't want to provide any concrete? No concrete methods. You only want to provide the interface. You only want to provide the API. You only want to provide the fact that all animals will be able to eat, all animals will be able to walk, and all animals will be able to run. But you don't care about how they eat, how they walk, how they run. They will be provided by the appropriate subclasses or whoever extend them. So that is called pure abstraction. That is called pure abstraction. So in the abstract classes case, we have both abstract and concrete methods. If you say that no concrete methods at all, pure abstraction, meaning it contains only abstract methods. And this concept in Java is called interfaces. So there is a type, like how we have classes, there is a type called interface. And if you define interface, they're exactly like classes, but instead of use the word class, you use the word interface, and then it contains only abstract methods and no concrete methods at all. No concrete methods. You provide only the abstract methods. In fact, you will only provide abstract methods that you don't even have to use the keyword abstract. You don't have to use the keyword abstract because all the methods in an interface contains only abstract methods. You don't even have to provide the keyword. And all the methods in an interface are public. So this is a pure abstraction. Then you may be wondering, okay, when there is no implementation, only interface, so what's the benefit of it? Well, what you are providing is just API, or a way to tell public that if you use my interface, okay, at runtime, callers will provide the appropriate subtypes. So you can safely, with confidence, you can call these methods like eat, walk, run, all these methods that you provided in this interface. These are abstract methods, but you can safely call them because the appropriate subtype will be passed to you at runtime. Right? So based on the appropriate type, you will call the appropriate eat method. If you pass dog, then dog methods eat will be called. If you pass cat, cat's run method will be called. If you pass something else, cow, then walk of cow will be called. And you are not getting any functionality from your interface. You are only getting the API. Since you're only getting the API and you are not getting any kind of implementation from it, it purely depends on what type you have passed at runtime. So this is the purest form of polymorphism. The reason it is purest form of polymorphism is because you are not getting any functionality from your interface. It purely depends what type that you have passed at runtime. If you pass cat, it behaves like cat. If you pass dog, it behaves like dog. If you pass cow, it behaves like a cow. All the methods will be called on your cow. Are you getting it? So in interfaces, which is pure abstraction and the purest form of polymorphism, this is the culmination of all the polymorphism that we talked about, because you're not getting anything from your dad. You are getting only the API. Everything depends on the appropriate type that is passed. Make sense? Any questions at this point? Or do you want me to look at shall we look at the code to understand what's going on under the hood? So Jyoti, you have a question regarding overriding. Let's talk.
So, Venkat, when we were talking about overriding and overloading, especially during overriding, for the access modifiers, you mentioned that the scope of these access modifiers, we can bump it up.
Yes.
Correct?
Mm-hmm.
So this is what is my understanding. So suppose in the parent class I have a public method.
Okay.
So in the child class I can bump it up to only public because that is being the supreme.
You got it.
Okay. And then suppose I have the default.
Okay.
In the parent.
Yep.
So I can bump it up to default, protected, and public.
You got it.
Correct?
You got it.
Okay. And suppose I have a protected type method in the parent class, then I can just bump it up to protected or public.
You got it.
But when I have the private method in the parent class, I cannot apply this overriding, correct?
You got it. Precisely. Because that is not visible to your subclass.
Yeah.
Exactly. Your private methods, forget about overriding for a second. Your private methods are not visible to your subclasses. If they are not visible, there is no point in overriding at all. So let me rephrase this one. Let's look at it one more time, right? Overriding comes into picture if I don't like the functionality that I inherited from my parent. I did not and I do not inherit any private methods from my parent. Private is the is the private property or private method of my parent. I don't inherit private stuff from my dad. Agree? It doesn't even come to the subclass. Are you with me?
Yes.
So then there is no point of overriding that. Overriding is nothing but changing the functionality that I'm getting from my dad. When I'm not even getting it, there's no point of overriding. You agree with me?
Yes, I got it. I had that clarification just to make it, if there is anything else that is like as a workaround, if anything.
But I just concluded based on what we talked about. You agree with that statement, right? Because overriding comes into picture. Simple. Overriding is nothing but, hey, I don't like what I got from my dad. I want to change. I want to provide my own. I want to override it.
Yes.
So.
I got it.
Fantastic. So let's look at it.
And whenever you have some time, since we just started this interface concept, but can you just go a little bit, can you just explain a little bit more on the method resolution?
Method resolution, huh?
Yes.
Okay. Give me some time.
No problem.
Okay. Okay. So let's talk about the interfaces, right? So we talked about the interfaces, the concept, and then let's look at an example, right? So see here, new class. Similarly, you have a new interface. The only difference between class and interface is nothing but you have this, I'll call this animal. Now, public interface animal. See here, instead of saying public class now, you have this animal. In fact, this is not a good real-time example. All the interfaces they will go one level above. Animal can be somewhat concrete too, but if I really want to go into the real details, right? So animal also can provide certain details that are common across all of them. But interfaces are typically like let's say movable. Okay, so let's say movable. All the animals or all the things that can move, I'll call an interface called movable. So all the movables will move. Okay, maybe animals, all the animals are also movable, right? So we can say that your animal supertype is movable. You know what I'm saying? So let's leave the animal as class. Okay, but now I'm creating an interface called movable. I'm calling this interface called movable. Now I wanted to say that all the movables will move, right? I'll say move. See, like this. So I don't need to say public here because all the methods in an interface are public. Because I'm not providing any functionality, then obviously somebody has to implement, somebody has to provide the somebody has to provide the implementation for this one. So that's why all the methods are public, and then you don't need to call this as abstract because it doesn't harm. You can go ahead and put public abstract. That's not a problem at all. But you don't need to put public. You don't need to put abstract because they are implicitly public and they are implicitly abstract because interface contains only abstract methods, no concrete methods at all. You can never write code like this. You can never write. Look at it. Abstract methods do not specify a body. So abstract methods do not specify a body. So you will never have a method body. You will only have method signatures. So movable interface has a method called move, right? Now anybody can move, not only animals. What other things can move? Probably your car can implement this. Car can provide the implementation for this move too, because car is also movable. All the vehicles are movable. Yes, thanks, Uma. Right? So it's a very, very generic. It's a pure abstraction. And we don't care about how they move. Animals move one way, vehicles move another way. So that is why we don't provide any kind of implementation here. Make sense? So now we'll say that animal supertype is movable is what we are saying, but we don't say animal extends movable like the classes. We rather say we use a different keyword here called implements. Okay? Your class extends another class, but your class implements an interface. Since movable is an interface, you will use this keyword called implements. So animal implements movable. Now your compiler is immediately complaining, saying that sorry boss, your animal implements movable, but there is an abstract method in movable interface that you must implement. That is what happens when you extend an abstract class, right? If you have an abstract method in your superclass, then you must implement it. If you don't want to implement, there is a way you declare your class as abstract so that you don't have to provide the implementation, and somebody else like a dog and cat, who are the subtypes of animals, they come and provide the interface. Anyways, but I'm not putting that concept here. We'll talk about that later. So anyways, public class animal implements movable. Now I'm doing a control 1 here, add unimplemented methods. See, automatically doing a to override, public void move, and now you provide your implementers. You provide your implementations. Animal is moving, etc. Okay? Now, so animal implements movable. Now let's say that there is an let's say there is an interface called eatable. What is one of you help me? Is eatable correct? Or I wanted to say that everybody who eats, I wanted to say eatable. That could be animals, that could be human beings, that could be anybody. So is eatable the right name? I'm talking about English name. Or anything? Is there a better English name for that? Let's say eatable. Okay. So all the all the animals, human beings, all of them who eat, they come under this category called eatable interface. So I'll say wide eat. All of them eat. That's what I wanted to say. Right. Now you can go on and on interfaces. Now, I know I told you about this multiple inheritance. Earlier we talked about multiple inheritance is not possible in Java, right? But now you have movable one side, movable interface, and then you have eatable on the other side. Now you have animal. Animal can move and animal can eat. Animal does move, animal does eat, right? In the case of interfaces, it is possible to implement more than one interface. So Java achieves the multiple inheritance concept with interfaces. So it will let you implement more than one interfaces. So you can say that your animal implements mobile and also eatable. You can say that. So now, but of course there is a method in eatable that you have to provide the implementation for. Control 1, add unimplemented methods, or you can do a control 1 or right click here. Sorry, just click on this one here and then provide the implementation. And now I'll say that that's it. Animals eat, and then you can say animal moves or animals move. Okay. So multiple inheritance is not possible through concrete classes, but multiple inheritance is possible through interfaces, because interface is pure abstract and it provides no implementation. So there is no conflict there because you are not getting any implementation. Everything is implemented by animal itself. You're only getting the interface, you're only getting the API, you're only getting the method signature. You're not getting the method body from mobile or eatable interfaces. So you can provide the implementation for both of them, and that is why it is possible to implement more than one interfaces. So this is one of the popular interview questions. Does Java allow multiple inheritance? No, it does not allow multiple inheritance through concrete classes, but it does allow the multiple inheritance through interfaces, because interfaces provide no functionality. It only provides the API, so your subclasses or implementation classes can provide the implementation by implementing multiple interfaces. Look at it. So your animal can move and it does eat, and it's movable and eatable. You have your own move and eat, and then you can have other methods of animal. Move and eat. What else can animals do? Walk, let's say. Probably your mobile can have that walk too, and fly. All the animals can fly. Okay, let's say in our world, okay. You brought up an interesting point, Yuri. Especially this method, I like it, fly. So animals fly. Okay. So now let's say dog, right? Now you can say dog extends animal. That's it. So just by extending animal, now it automatically got your move functionality, eat functionality, and fly functionality too. Okay. So now dog can actually fly now. Can dog fly? Can dog fly? No. But you're automatically getting the functionality from your, if you don't do anything about it, you can make your dog fly. If you don't do anything about it, let's say interface demo. Animal A equal to new dog. Okay. See, you're getting eat from your eatable, and you're getting move from your movable, and you're getting your fly from your animal parent class itself. Your dog is getting that way, right? So these two you're getting from the API, you are getting from movable and eatable, but implementation you're getting it in animal. So if you don't like the functionality that you got, if you don't like the functionality that you got from your animal, and in your fly, you can say that, let's say the fly, right? You don't like the functionality that you have got from your animal. I'm not saying this is the good idea. I'm only saying one way to do it. Okay? So in my opinion, this is a bad design. Not in my opinion. You ask anybody, I think it's a standard. It's a fact that it's a bad design. But I'm just showing you one way to do it is. Since dogs don't fly, but animals automatically, you are getting the fly functionality from dog, you are getting the fly functionality from animal. So every animal that you extend from animal will automatically get the fly. But since dogs don't fly, then we want to override it and provide a different functionality, saying that dogs don't fly. Okay? You can override it. And you talk about cat, same thing. You talk about cow, same thing. So it's a bad idea to put fly. I'm sorry, I'm not saying anything bad, Yuri. That's why you brought up an interesting point. I can make a point here that because your cat also can override, not can override, it must override and say that cats don't fly, dogs don't fly, your cows don't fly. And in fact, the providing, now let's say there is a class and that is accepting animal class. Now you can provide any subtype of animal, right? You can provide dog, you can provide cat, you can provide anything. Now, since he's accepting animal, he can call any method on the animal, including the fly, right? But ideally, fly doesn't exist. So it's generally a bad idea to put fly method in animal, because not all animals do fly. Okay? Now, if you take a bird, what you can do is you can do this way. You can, how do I say flyable, or you can definitely do an interface like this, flyable, and then you can say void fly. Okay? And now you can have your bird. Bird is an animal, right? Bird is an animal. So you are extending bird, but you are adding another interface called flyable. You guys like that? Public class bird extends animal implements flyable. Right? So now you are providing the functionality for your fly. You say that agree? So now I can take out from this animal. So animals don't fly. Rather, there is another interface called flyable. All the relevant pieces, all the relevant animals will implement that interface. Now you can say animal A equal to new dog. Okay? Now, animal A equal to, yeah, swimmable. Yeah, exactly. That's another thing. Yesterday, somebody was asking if it is a breed of two different, two different parents. Hey, can I do that? Yesterday, Rohit was asking, right? So, can I extend both of them? If there is like a donkey, is a donkey or something that comes from two different breeds, right? In that case, your concrete inheritance is not possible because you are trying to extend more than one class, but you can do is perfectly like this. Okay? So, swimmable. Let's say frog, right? So, frog implements swimmable, and then let's say there is another interface where you can live on the ground. This because this can do both, live in water and then live on the ground too, right? What is the other one called? Let's say mobile, for lack of better term. So your frog now, it implements mobile, it can move on the ground and it can swim in the water too, right? It can do both. Yep. Now, you understand? Now, one small point I need to mention here. Since we talked about animal and bird here, all these while I've been talking about polymorphism, etc., right? Let's say there is a class like animal feeder. Okay? Let's say there is an animal feeder, like how we discussed it yesterday and day before. And I'll say feed, and I'm accepting an animal. Sorry. Okay? I'll say animal.eat. This is fantastic. Now, for example, in this feed, I need to be able to make my bird fly also. I want to call the fly method of the bird. Can I do that? Can any of you tell me, can I do this one? A.fly. Can I do this? It cannot. Forget about your JVM at runtime. Your compiler is going to say that there is no method called fly in animal. You cannot. how do I do that? Because I want to, as part of the bird's feeding, I'll feed them and then I have to make them fly. Then they digest easily. Let's say that's a functionality. Okay. So here, by accepting animal, every animal is different. Once they eat, they're good. But for birds, I have to make them eat and then I have to make them fly. How do I do that? If you need to use the specific method of bird that you need to use, then you have no option. You have to go out of the polymorphism. Then you don't provide. So let's provide one more method called feed, and then you provide bird B, let's say. So let's say you make them fly. You make them fly before they eat. That's the functionality here. Okay, see here. Now I'm providing two different ways of feeding it. For all the other animals you can do it this way, but since bird is a very specific one, okay, you can use this guy here. So now for all the birds, you are flying them before eating. So here you are not achieving the polymorphism. You can only pass the bird or any of the subtypes of the bird if there are any specific birds. Let's say there is a canary extens bird. Okay. Robin extends bird. If you are doing any of that, then you can pass any of the subtypes of the birds here. But here, this is you can pass any animal. You can pass any animal. In fact, you're talking about feed, right? How about this one here? How about so here you can pass any animal. You can pass dog, you can pass cat, you can pass cow, anything. I can feed them. How about this one? Public void. This is the highest point of polymorphism. I'll say another feed. Now my question here is that, hey, should it be an animal? Should it be an animal? Can't I feed human beings? Why should it be? Why am I restricting myself to an animal? I am saying that any eatable, pass it across. I don't care. Pass it across any eatable, because there is an eat method here. You pass it to me any eatable. By saying this one, this is even more polymorphic. This is the highest point of polymorphism in this example. What you are saying is that eatable is an interface. So every subtype of it, it can be an animal. Animal implements eatable. Okay, your dog extends eatable. So you can pass dog, you can pass cow, you can pass animal, you can pass human being, you can pass anything that implements eatable. Are you getting it? And then here you can pass any animal. This is also polymorphism, but not as great as eatable. But here, bird, you are talking about a very specific animal here. So with this one, I'm not saying you don't do, I'm not saying one way or the other. Based on the requirements, we have to go for it. For here, for birds, the requirement is that they have to, as part of the feeding, first you have to make them exercise. You have to make them fly first and then feed them. You have to make them eat, right? So you provided a specific implementation for bird, but all the non-other birds, any other animal, they just eat. And then not only animals, you can pass any eatable object. That can be human being, that can be anybody else, and then pass this guy. Are you understanding now how polymorphism works? And by accepting interface here, that's why I was saying that it's a purest form of polymorphism, because here it's only you're restricting yourself to all the animals. But here it's not animals. It's any eatable object can be passed and I can feed them. Are you getting it? The same code is behaving differently based on the actual subtype. Can we talk for a couple of minutes? How many of you, I want to get an idea. Did you really get it? Or I confused successfully? Or everybody got that concept? Let me ask one at a time. Anup, did you get it?
Thank you.
Yeah, Uma, go ahead.
Yeah. Can you please open that animal eatable class?
Yep.
Okay. And animal, please.
Absolutely.
Okay. So can you go back to the animal feeder?
Definitely.
Okay. How is this animal feeder linked with eatable? You say in animal you say implements to the implements the interface, right? Movable and eatable.
Right. It is not a parent and child relationship, right? Your animal implements eatable, meaning animal implements eatable, right? So because this is one of those eatable, what do you call? Eatable creature, right? Eatable creature, right? You know what I'm saying? So animal implements eatable, and animal implements movable, because animal can eat, animal does eat, animal does move, right?
Yeah.
Now, the animal feeder, does not belong to this hierarchy.
Okay.
Animal feeder is a separate class. Let's talk about it, if that's what confuses you. So on this side you have eatable, and you have movable, and you have animal, you have dog, you have cat, etc. And yesterday you have a pug or something, right? So pug extends dog, dog extends animal, cat extends animal, animal implements eatable, animal implements mobile too. Right? This is your object hierarchy. Now, on the other side, now, since we designed this way, I want to take advantage of it, right? So there is a separate automated machine called animal feeder. Now my point is, here there is a feed method. My point is, this animal feeder, you can write it just for today, meaning today the requirement is that pug needs to eat. Pug needs to be able to eat. So you can say feed pug, definitely. This definitely works. And your pug, you pass your pug, definitely works. Okay, but all you're doing inside is, whatever, pug p probably, all you're doing is you're calling the eat method, right? All you're doing is calling the eat method. And calling the eat method is not specific to pug. If you're using any specific method of pug, I agree with it. You sacrifice your polymorphism for it. But your eat method, you are getting it from where? From here. Your eat method is in eatable. In the hierarchy, you're not getting it from dog, you're not getting it from animal, you're actually getting it from eatable. You're all the way getting it here. So rather than accepting pug, you can also say dog. Okay, because there is an eat method in dog also, right? Then you are expanding your design more, meaning not only pug, any other dog too. Let's say, I don't know what it is, but any other subclasses of dog can be passed here. Agree? But let's say I want to expand a little more. Now I'm not using dog also, I'm using animal. If I use animal, then you can pass dog, you can pass any of the subclasses of dog, and also you can pass cat, you can pass cow, any of the subclasses of cow, any of the subclasses of cow. So you're broadening. So the same code, your animal feeder will behave based on the actual type that is passed, because you are coding to super type. You're coding to top classes, you're coding to super type. Now if you say that, no, not only animal, eatable, right? Human being. Human being is also implementing eatable. Okay, again, maybe here we have a couple of types, etc. Right? But now by saying here animal, I'm restricting myself to animal hierarchy. Why? If I change it to eatable, because I'm not using any specific methods that are coming from animal. I'm only doing P.8, then why not eatable is my point. If you provide eatable, in this whole hierarchy, any class can be passed, any object can be passed. You can pass human being into this one and have him fed. You can pass pug, you can pass dog, you can pass cat, you can pass cow, you can pass animal. The same code polymorphically calls the eat method based on the actual type that is passed. Now we are expanding our horizon. Did you get that, Uma? But it's not for Uma. She brought up a great point, so I wanted to make this clear. So did you all understand now how polymorphism works and how code to supertype, code to interface? I'll call it code to interface because interface is the top form, right? The toppest. Right? Can I safely say that? So if you code to interface or if you code to super type, the beauty is that you can achieve polymorphism. You can pass any of the subtypes.
So Hari, one question.
Before that, Venkat, sorry. Before that, let's make sure, let's stick to this point and see whether we understood it. So Uma, first of all, did you understand what I said? Is it clear?
Yes, I understand this concept, but I am missing one link in between.
Yeah.
That is, if you could go to the, here. See, movable, eatable, both are interface, right? So this one is animal implements both movable and eatable. Okay, and dog is extends animal.
Okay.
Okay, and flyable extends, or flyable is,
I mean,
flyable
your
extends
bird
bird.
extends flyable.
Bird extends. So this animal feeder, it's not linked into any of these classes, right? So how do you?
That's my point, right? It is
not.
not. Go ahead.
Yeah. So if we want to access that super whatever term we used just now, so there is no need to link anything, right? We can just
Exactly.
use this like this.
This is outside of the hierarchy, Uma. That's my point.
Okay.
It is outside of the hierarchy, but this guy, this is where my polymorphism concept, because you have this object hierarchy like this, okay? Have your methods accept as top classes, as super type as you can, so that you can achieve a polymorphism is my point.
Okay, got it. Okay.
Agree?
Yeah. So I can also create another class related to these terms and then call eatable or movable or something similar to that, right? If I create an interface. Am I right?
Say that again.
You created an animal feeder now, so I will create some other class related to animal feeder, and still I can, if it is related to this eatable, movable, or you call some other function like running or something, so I can call that, right? That's my understanding.
I did not get the question though,
Not
so
get
I
my
can.
point, right? Yeah.
No.
See, like animal feeder, similarly, I can create another class too.
You can.
I can call
Absolutely.
these, and I
Absolutely.
can call these interfaces.
Absolutely. Absolutely.
Okay.
Absolutely.
Okay. Thanks.
So all my point is, okay, my point here is that when you design these classes, you have this perfect hierarchy here, right? So in your hierarchy, in your class hierarchy, always code to super type, meaning accept pug only if you absolutely need to. In your methods, go ahead and accept pug. I'm not saying that's a sin or something. Okay, go ahead and accept pug if you absolutely need to use the functionality that is provided by pug. But if you want to use a method like eat, there is no reason to accept pug and restrict yourself, because you can't pass a dog there. You can't pass a cat. You can't pass a human being, because you're eating. All you're doing is calling the eat method, which is coming from eatable. So go as high as possible so that you will achieve this higher level of polymorphism. The same code you don't have to touch tomorrow if you have to pass human being, is my point. Right? Okay, Venkat Krishna.
Yeah, got it. Yeah, thanks.
Yep. Okay, to make this... Sorry, go ahead.
The question I had was, I think you answered it. If you pass eatable, I can access all the methods, right, of dog, cat.
Nope. No.
Assuming that eatable is pointing to the dog object.
No, sir. So, in eatable, see here, in eatable, how many methods we have? Only one method, right?
Okay. Only one method you can. Okay.
I can only access that one method. And I can't say that e dot move or anything like that, or e dot. There is a fetch method in dog. Unfortunately, I can't.
Got it.
Because your compiler does not let you do that. Because compiler says that's my point, right? So your compiler says that, sorry boss, there is no method called fetch in eatable interface. You have to use only the methods that you have in eatable.
Okay, got it.
Okay, but the point is, if you are only using C, if you have to use fetch method for some reason, Venkat, right?
Yeah, then I would go animal.
Then I would go either animal or dog. Let's say there is no fetch in animal. Then, fetch starts from dog. Then I will go for dog.
Yeah.
Then I'll go for dog. But if I'm only using eat, then I don't want to do dog. I mean, I can. This definitely works. My point is that when you're using only the eat method, which is coming from eatable, why are you restricting yourself to dog? So now, now you are restricting yourself to only dog family, dog and dog below the hierarchy. But if you put it eatable here, okay, or let's say animal here, then you are increasing your horizon little more, that you are extending it to all the animal family. But it doesn't have to be animal also. It can be eatable, because you're only using the eat method that's coming from this one.
Got it.
Got it?
Yep.
And if at all, I'm telling you again, if at all, if anybody has any lingering doubts, right, we'll talk about this concept for lot more times. So especially in collection, I'll make it. Now you may not be able to comprehend it completely, but in collections I'll show you with examples what I meant here. Okay? So in another next couple of
I have.
classes, this concept will be absolutely clear. Okay, before that, Madhavi, 1 second. Deshkan did some. He just raised a point here. I'm just. We can implement more than one interface and extends only one abstract class. It's not only for abstract class, even pure concrete class. The point is you can implement more than one interfaces, but you can extend only one class. Period. And since you brought up that point, I will add one more extra point here. What that one is? So the fundamental point we are making here is that we can implement more than one interface, right? But you can extend only one. So this is very popular interview question too. Then which one would you go for? If you have the option of both extending a class and implementing an interface, which one would you go for? Then the answer is implementing an interface. The reason you would go for implementing an interface is extends only one class. You cannot extend more than one class. So then leave that extends. If you just do extends class something, extends animal, then your class design is frozen from inheritance point of view, meaning you cannot extend one more class. So always leave this for future. Okay, so in other words, your extends is a very scarce resource. So use it for future, use it carefully. So go ahead and if you're achieving the same thing, go ahead and implement your interface, because you can implement more than one interface and keep this extends for future. Okay, because the moment you keep extends, then you're done, right? You can't extend on more. That's my point. And Madhavi, you were trying to say something and I cut you off.
Yeah, if we implement two interface, then this class get all methods from the two interface?
Absolutely got it. Yes.
Okay.
It gets from both the interfaces.
Okay. Thank you.
No problem. That's about the interfaces. Can you open up animal.java and eatable just for a few seconds? Yeah. Go ahead, Jyoti. And you have eatable. Okay. Wonderful. That's all? Okay. Interfaces, pure polymorphism. Okay. So this coming Tuesday and Thursday, we don't have any classes. This 2 days. I'm going for some training. So that is why I want to start off the collections framework today, so that I can give some homework these 2 days, and also I want you to watch a couple of videos. I'll talk about it in a few minutes. So let's start on the collection framework.
I have a question.
Yes.
Can we talk final classes also today?
Yes.
Okay.
Actually, let's talk about it. I was thinking probably for another day, but I think it's a perfect time for that, you know. Let's talk about that. Perfect time, and then I'll talk about, while designing how to decide what would be a club class and what would qualify to be an interface subclass. Okay. While designing You want to talk rather than texting, Venkat, so that we can have some conversation? I'll understand what you are saying.
Yes, yes,
More clearly.
yes, Venkat. Yeah, just so how would you categorize? Okay, this one I need to be an interface. That this one is better to be a class. How do you do that while designing
Very
a
good.
class? Yeah.
Very good. Very good. Very good point. Very good point. So, if you only want to provide the API just like this, no functionality, nothing. Just want to make sure that all the classes that implement this will have the same method signature. Okay. Then you will go for interface. All the top level ones, you will go for interface. But at some point, you have a lot of functionality in your class. Okay, you have a lot of functionality that you want to reuse it in your subclasses. You don't want to see. One point I wanted to bring up in interfaces is that if you put everything in an interface, so if you have, let's say you design your animal itself as an interface and you have 100 animals, so every single method that you put in your animal is getting duplicated in all of them, right? So you are not reusing any of the functionality. So in case of reusing, you go for extends your class design. Okay, but purely for API adhesions and pure form of polymorphism, you will go for interfaces. Actually, for that, there is a little more maturity is required to even talk about it. I will talk about it later. There is a concept called favor. We'll talk about favor. Not getting the word. Favor. Is a word. So don't favor inheritance, rather favor.
It's a design concept. Huh?
Yes, it's a design concept. Favor. What is that called? I'm not getting that. Drawing blank here. You always actually, rather than favoring your inheritance, you favor composition. Exactly. So favor composition over inheritance. So there is a design concept like this, and to be able to talk about it, we need a lot more maturity. So I don't want to talk about that one. We'll talk about it later when we talk about the design patterns or the solid design principles. Okay.
Okay.
So yeah, at that time I'll talk about it. So let me talk about final. Okay. So final. In Java, there is a keyword called final. Okay. Final means final. It has actually 3 different meanings in 3 different contexts. It has 3 different meanings in 3 different contexts. So you can use final for a variable, your field, right? Instance variables. The final variables, once you initialize them, you can't change them. You can't change the value of a variable. You can't change the value of a variable. Okay. So in your car example, you said you have your maximum speed, right? It makes sense to define your maximum speed as final. So you say that private, okay, final int max speed equal to 140. And anywhere in your code, see earlier we didn't put final here, right? So every car will get the maximum speed of 140. But what happens if somebody comes back in your in your accelerate method or somewhere in any of your methods you can do this, right? Max speed equal to max speed plus 50 or max speed equal to 500. You can do it. But if you declare this as a final here, you will use like this, private final int max speed equal to 140. Then if you try to do it here, your compiler itself will slap us and say that, sorry boss, this is a final variable and final variable cannot be changed once it is initialized. Okay? And final can be used in front of method 2. Then you say like a public final void move. Okay. If you put it as part of your method, this means that final methods cannot be overridden. Final methods can't be overridden. Meaning, in your subclasses, you cannot override them. Whatever the functionality that you get from your dad, that's it. You cannot change that functionality. If I absolutely want to make sure that I need to give the flexibility wherever I need to give, but I need to tighten up wherever I need to. Okay? So let's say that there is a Pizza Hut, right? So Pizza Hut, for every franchise, so let's say there is a pizza class, okay? And then they will write certain methods that every franchise can override and provide their own functionality, but there are certain things that you will get it from the headquarters of Pizza Hut that you cannot change, right? Any of the franchise cannot change, but certain things can be changed. So those things that cannot be overridden, declare them as final methods, and final methods cannot be overridden. And final has the third context, the class also. When you say public class like this, you can say public final class. Public final class pizza, if you just say like that. Okay? And final classes cannot be subclassed. Final classes cannot be subclassed. Final classes cannot be subclassed. So you don't want anyone to subclass your class. Okay? In that case, you declare your class as final, and then nobody can say that my class extends this one. No, you can't do it. Okay. So this is actually one of the very important interview questions too. What's the final keyword? And later we'll talk about it. When we talk about exception handling, we'll talk about finally keyword. It's a different keyword. So they ask typically, what's the difference between final, finally, and finalize? There is a different method called finalize. So, and when you talk about final, you say that, hey, final has 3 different meanings in 3 different contexts. Final variables can't be changed once they've overridden. And final methods cannot be overridden, and final classes can be subclassed. So once you get the maturity in the overall design, we can decide. As I told you, final methods, where would you use the final methods? As I told you, in your pizza class, okay, certain things can be changed by franchises. But finally, you have your make pizza method. That has to be final, in my opinion, because you have to do pizza this way. Otherwise, you will lose that the Pizza Hut brand name, right? So there you don't want to give the flexibility to your franchises. So that one will be final. And as I told you, final variables, maximum speed is a perfect example for final. And you don't want that to ever be changed. Absolutely no. You don't want to give it to anyone. By intentionally or unintentionally, you don't want that to be changed. And final classes, and you don't want anyone to absolutely extend it. You don't want anyone to extend that. Okay, so whatever the functionality that I'm giving it, that's all. You cannot subclass it. Later I'll talk about some very good examples. We will look at it in the Java API itself. I will show you some classes that we use it on a day-to-day basis. Okay. One of the classic examples, if you ask me, right now is the string. Your string class is final. You can't subclass your string and provide your own. You can't provide your own implementation because you don't want to change the functionality of it. That's how it works. That's how it works. That's how. So those are final classes. That's about the final. No, nothing else from the final perspective. Now, is it complete concept or BAPI or technical concept? I didn't understand.
Sorry, Venkat, that is not group.
Okay, sure.
Okay.
Is it for me
Sorry.
or?
No, it's for Ravi.
Oh, okay, got it.
Something.
So, let's talk about the collections framework. So far we talked about objects and then object-oriented programming features, etc. Right? We talked about encapsulation, inheritance abstraction, and pure abstraction in the form of interfaces and polymorphism, etc., etc. Now let's change the mood to onto something else and talk about something entirely different. Okay. So we have the objects, right? Now, we don't deal with these objects in like one object, like one animal, one cat, one dog, like that, right? We always deal with the collection of objects. We say that collection of dog objects, meaning collection, when I say, I meant more number than one, right? Like an array. So array of dogs or collection of dogs. Okay? Or collection of animals, collection of bugs. So whenever you deal with more than one group of objects, that's when we use collections. And Java has provided exhaustive API and several interfaces and several classes to deal with the collections on a day-to-day basis. Whenever you need to deal with more than one class, then more than one object, you want to put all the dogs into a basket. You want to put all the cows into a separate a bag, a big bag. Okay. So all of them are here in the collections framework. Collections actually, they put it as all the related classes and interfaces, they put it as a separate unit and they called it collections framework. In the collections framework, we have several interfaces and several classes. And here, on top of the collections interfaces and classes, we have this interface called collection. We have this interface called collection. Collection is a top level interface. There is one more level above collection too, but I'm not talking about it right now, called iterable. We'll talk about that later. This collection interface is nothing but, it is a bag that holds group of something, group of objects. It allows you to add an object to the basket. It also allows you to go through each item inside the basket. That going through each item inside an object is called iterating. Okay, you can go through, you can iterate through all the objects in the bag. So your collection is nothing but a bag. So let's say you created laptop objects, okay, and you want to send these, rather than, you want to send all of these laptop objects to a retailer, okay, so that he will sell the individual laptops, right? So you need to give this collection of laptops to that guy, to that object. So you need to, you're not giving one laptop object here. All these while we talked about one laptop object, but I'm talking about multiple laptop objects. I'm talking about the collection of our laptop objects. I'll put all of these collection of laptop objects into a big basket, and then I'll give that. That basket is nothing but a collection. Okay, so it helps you add, it helps you iterate, it helps you remove everything. Okay, so now you may have, typically you may have two kinds of requirements, right? What that one is, if you add something to the bag, maybe you want to maintain the order. Maybe you want to maintain the order of the items that you are adding. Let's say this is a bag, right? Bag. And you're adding laptop 1, laptop 2, laptop 3 in this order. You added these items into a bag. And now, when I'm asking this bag to iterate through this one, hey, can you give me all the objects? Or actually, let me put it this way. All these objects, you want them to be stored in the order that you gave it to the bag. You want to maintain the order. You want an ordered collection. So if I add to the bag L1, L2, L3, what this bag does behind the scenes is it will maintain the order. It will remember that you gave L1 first, you gave L2 next, you gave L3 next. When you ask it to give it back, it gives you in that order. It doesn't lose the order. That is nothing but an ordered collection. So there is a different interface called list to maintain the order. And list is nothing but an ordered collection. In the bag, it maintains the order. And then there is another interface called set. This set interface does not accept any it's not ordered. Not ordered, meaning when you put it L1, L2, L3, it will put it randomly based on certain criteria. We'll talk about those algorithms later. But you give me L1, I'll put it somewhere. You give me laptop 2, I'll put it somewhere. You give me laptop 3, I'll put it somewhere. When you ask me, I will not maintain the order that you provided to me. So don't assume that I will maintain your order. I will not maintain your order. But set actually does not take any duplicates. If you try to give me the same laptop one more time, I do not accept it. I do not accept duplicates in set. No duplicates. It's like a mathematical set. You know, in mathematics we have that math set, right? That set does not accept duplicates too, right? So this set actually resembles that one, and the list accepts duplicates. Yes, duplicates. And then it maintains the order. Early on in our classes, we talked about something called arrays, right? So arrays are also data structures where you can store the group of similar objects, right? But there are two disadvantages. You may be asking this question, hey, then what's the point in providing again collection interface when you have arrays? Well, there are two biggest disadvantages. One of them is, now we talked about all the objects and object-oriented programming principles, etc. Arrays are not really objects. They are not real. They're not really objects. Okay? There is no concept of polymorphism, and there is no concept of overriding, encapsulation, not that much. Okay? These are actually not real objects. They're actually kind of data structures. That's all. Okay? There is only one method in arrays that you can use called length, but they're not real objects. But we want real objects and real interfaces, real implementation, so that we can take advantage of it, right? We can take advantage of all the object-oriented principles. And number two, they are fixed size. I mentioned this at the time. They are fixed size. They are fixed size. One, the biggest disadvantage is they are not true objects, so you don't have a lot of behavior in them. That's exact point. They don't have a lot of behavior in them. Okay? And they can definitely manage the, give your objects, it will store them nicely next to each other. And then you ask array of, can you give me a ninth element? It will give you the ninth index object. But nothing more than that. Can you set this object at the ninth position? Yes, it can do it. And you can get the length, but no behavior on top of it. If you want to do something on all the objects, you can't do it. Because they are not, under the hood, they are not real objects. And the second disadvantage is they are fixed size. So you have to know upfront in arrays concept that what would be the size of your array. You have to know at the time of creation of the array itself that, oh, my array, you know what, I would need an array for 10 objects. How many times do you know in real world upfront the size of your bag? You wouldn't know. I need something that as I add the items that should automatically grow. So I added 10 laptops. Okay. When I try to add the 11th one, don't tell me that your bag is full. You can't take the 11th one. You expand your bag. You grow in size automatically. That is the beauty of collection interfaces. So here, these grow automatically. They are not fixed in size. You don't have to know upfront the size of the collection, size of the bag. You don't have to know. That is why we needed, and these are all first class objects. They have both state and they have behavior. They have excellent behavior. There are a lot of methods. Okay? So there is a top class interface called collection, and there are two sub interfaces called list and set. List is an ordered collection. It maintains the order, and yes, it takes the duplicates, and set does not take duplicates and it does not maintain any order. But these are just interfaces. As I told you, interfaces, there is no implementation. There's only API. There are methods to add, and there are methods to get it. There are methods to remove it. There are methods to iterate through it to get all of the methods in a bag. You have all the methods. Then who provides the actual implementation? Somebody has to adhere to these principles, right? When you say list maintains the order, but you're saying list is an interface. Interface does not come up with any implementation, right? Then who maintains it? Well, there are implementation classes. As I said, this whole collection interface is pure object-oriented. So there is a class called array list. There is a class called array list. This is a low-level class. This array list class implements your list interface. Okay? Meaning, this is the one that is actually doing the dirty work. This is the one that is doing the dirty work. It will implement your list interface in such a way that, one, it maintains the order. It maintains the order. And number two, it allows duplicates. It allows the duplicates. So there is a underlying class called array list. And there are more implementations to it. There is one more implementation called linked list. There is one more implementation called linked list. We'll talk about that later. But let's talk about array list, right? Let's talk about array list for a second. So array list is it implements list interface. What does it mean? It implements list interface and provides the implementation in such a way that, one, it maintains the order, and number two, it allows duplicates, and number zero, the first and foremost thing is it grows and shrinks automatically. That's the beauty of collections framework, right? It grows and shrinks automatically. Grows and shrinks automatically. Let's say you have a bag and you added 3 cows. Okay? Let's say you added 10 more cows here, and then it automatically increased the size. Let's say you removed 10 cows from here, then it automatically shrinks. Okay? You know how it does actually? If you really want to know under the hood what happens with this array list implementation, actually under the hood, it uses your array data structures. Whatever we talked about earlier, it uses arrays. But you said arrays are fixed length, right? Yes, arrays are fixed length. So what it does in the array list is, let's say you asked it to, you said new array list. So meaning you created new array list. Okay? Then you asked it to create a new bag, right? It created a new bag. You know what it does? It behind the scenes creates an array with certain size. Let's say the size is 10. Okay. So it creates an array with the size 10. And now what you do is it will maintain the order. I mean, in arrays, it will index, right? 0, 1, 2, 3, 4, etc. Now you add the first cow here, C1. It will put it in the 0th position. You add the second cow here. It will, this is the cow 2, cow 3, etc. Okay. Now you add the 11th cow here, C10 or C11. You add the 11th cow here, but arrays are fixed size and there are only, it created, whenever you asked it to start, it only created an array with 10 size, right? What happens is, it will realize at the 11th element that, oh, my array is full. But collections framework says that this bag needs to grow and shrink automatically. So it will realize that, oh boy, all the 10 positions are full, then my array is full. Then what it does is, it will behind the scenes create a new array. And now this time, every time it grows by a factor, whatever that factor is. Let's say the factor is, every time you grow like 3/4 of it. Okay, so 3/4 of 10, right? Let's say 7.5. Okay, so 10 to 8. So it will grow 8 more, so 18. So it will create a brand new array with the size 18. And now it will copy all the elements into this one. Array list behind the scenes does that for you. You don't have to worry about it. I'm telling you what exactly happens behind the scenes in array list. So array list behind the scenes uses array data structure. But every time the array is full, it will create a new array and then copies all the elements from the old array to the new array. Now, this is the 11th element. This is C11 here. And it still has 7 more fields. And now you added 18, right? Now let's say cow 19 is added. You don't know any of it. You don't know what exactly is going on behind the scenes. You just keep adding as if you don't know anything about it. Now it will grow. Now it will grow again, not 18. Now it will, based on that factor, let's say to 25. Okay, now your 19th element gets added here. So all the elements here will get copied over to this one. Behind the scenes, all the dirty work is done. So this is how it maintains the order, by the way. I said it maintains the order, right? How does it maintain the order? Because under the hood, it uses the arrays. And array data structures is positional based, right? So it will maintain when you give me the new one, I'll add to the next one here. Now you add 12th cow, I will add here. You add the 13th, I'll add here. Like this. Okay? And what happens, maybe it also allows you to remove the stuff, right? Let's say you removed 10 cows now. Okay, let's say you removed 10 cows. Then it will figure out that, hey, once I remove the new cows, what would be the new size? Well, the new size currently is 25, minus 10 is 15. So based on that, it will create the new array here, and then it's not exactly 15. It will apply some factor to it, and then it will copy all the elements into this one. Okay, it will copy all the elements into the new array. So you don't have to know what is going on. You can keep adding. You can keep adding, you can keep deleting, you can do it. So that is about array list. Jyoti, yes, the previous one is no longer there, always the latest stage. So now we have 3 arrays in total, or once copied, the previous one is deleted. Oh, okay, no, the previous one is gone. The previous one is completely gone. That's a very good question. The previous arrays are all gone. Now, this array list is backed by this array data structure. That's it. And now, again, keep adding, it will grow. Keep removing, it will shrink. Keep adding, it will grow. So, but you don't have to know what array list does behind the scenes. All you know is you have this bag with the infinite capability. You just keep adding and also maintain, also understand that it can grow automatically, it can shrink automatically, and then you can keep adding, keep deleting, and then it maintains your order at any time. Anytime you need to find out how many cows you have in your truck, let's say this is truck, not a bag, it's same, right? Data structure. It maintains the order. The order in which you add it to the basket, it will retain that, and then it allows the duplicates. Make sense? On what concept array list is dynamic? Can you talk? Rohit, probably I'll understand what you're asking better, so I can answer better.
Yeah, actually, generally we say that the array list is generally dynamic, we call, right? So I
What?
wanted to know like what's some concept behind it, because you say right now it's working on the basis of arrays, but I don't think, as per my understanding, I don't think arrays are like really dynamic, because the size is fixed there, right? You can't like the array list, you can any number of elements. Suppose you declare, and later if you want, you can insert one more element into the number of like arrays whatever array list size you declared. But in arrays I can't do that. Once you size like 10 is fixed, I can't have any 11th element inserted again if I want in my program later in the as per the code. Now I want to understand what makes the array list dynamic when it is like almost working on the basis of arrays. How does it like making it a dynamic at all?
Can any of you answer that? I thought I just explained that, but can one of you answer it?
I mean, because I heard it's because of the collections helps it doing the extra functionality. Is it the right point?
No. This is the point, that the one we just discussed.
I mean, it's not overriding the existing array, and it's creating one new array based on some factor, and it's increasing size, and it's copying all those previous elements, right?
Precisely. Yeah. Now let's listen to more people. Venkat, you want to add something?
Yeah, I mean.
You want to answer his question?
Yeah, exactly. Because it's dynamically growing. Whenever it exceeds the out of bound or of the array, it will create a bigger array for you, making room for more objects. So it's dynamically increasing, dynamically decreasing. So that's the concept, I think.
I think Rohit is asking how is that happening, right?
If like an exception, like in the regular array, you have out of bound exception, right?
Yeah,
when this occurs, this is probably occurring, and it's handling that exception by giving you more room. That's what it's doing. It's same.
Yeah, how is it handling?
Who does that work? Basically, who does that work actually?
There is some code. Probably there is.
It is the collection, and there is the list, and it is maintained.
Okay. Let me.
Right.
So let's say, just for fun, right? Let's say, I'll explain. So let's say I created a class called Rohit's array list, right? Okay. So here, your array list is the actual data structure. Okay. So this Rohit's array list is also a data structure. Now, what I'm saying is, this is backed by the actual arrays itself. But Rohit's question is, hey, when arrays are static, meaning they can't grow, but how can the array list be dynamic? Well,
Exactly.
your array list is the data structure, meaning, let's say, so I'm maintaining here, okay? I'm maintaining, let's say that to make things simple, okay? Let's say that I will only accept animals, okay? Private animal array, okay? Animals. So, I'll say that to start with, my data structure to start with 10, right? Now, see here, public void add, you can add animal any number of times, right? Now, here, I'm backed by array data structure. Arrays are static. So I maintain the size and I maintain, though I know the size here, right? Animals.length will give me the current data structure size. Now I'll maintain private hint, how many objects do I have? How many animals? Okay, currently. Okay, and then every time you add, I will increase this guy here and then I'll see. Okay, first time it is 1, second time it's 2, 3, 4, etc. Now, look at this one. If you end up writing the implementation for array list, this is how we do it, right? If how many animals, how many do we have? Currently we have 10. Okay, if it is same as your array size, okay, length, okay, your array length, okay, okay. If so, then go ahead and create a new data. Now go ahead and create a new animal array. Now you say that new one equal to new animal. Okay. Currently the size plus 10. Let's say my simple algorithm does is whatever the currently size is, whatever this one is, and I grow by 10 every single time. Okay. So behind the scenes, I created a new data structure here. Sorry, I created a new array here. Now copy all of them from existing to the new one. Copy all these guys, okay, to the new one. So now all the objects are in this one, new one. Now I'll make my new one as my current one. Did you get it? So who is doing all the work? Your array list is doing it. Your array list has the code to automatically grow or shrink whenever you have it, whenever you need it, sir. So arrays are static, but array list is backed by arrays which will figure out whenever you add the 11th element, it will figure out that your array is full. Then it will create a new array, bigger array, and copy all the elements from the old array to the new one. Now your new array is your actual array. The old array is completely gone. Now how many objects can you take it? Initially you started with, let's say I always grow by 10, okay, just to make things simple. Under the hood, actually, you have something called factor, it multiplies by that factor. I'm not going into the details, okay? To keep things simple, I grow by 10. Initially, my array is 10, okay? Now, This is all in my array list, right? My array list dot add, this guy added 11th one. See, my code kicks in now. In the add method itself, I'll find out, oh, the size is currently, the size of the array is 10, and also I have 10 elements here. It's time to create the new array. So I'll go ahead and create the new array. So currently size is 10, and I'll grow by 10, right? Now I created a new array with 20. I created now. Now it's time to copy all of these guys into this one. Okay? And now, whatever the 11th element, 11th animal that you wanted to add, I will add here. Hey, now my bag is, now this array is gone completely. Now we have until 20. Now you keep adding 20, 19th, 20th. And now you are trying to add 21st element. At that time, the size and how many animals do I have, here it matches. It's time to, I can't take this 21st element because it's already, the bag is full. Now let me create a new bag. Who is doing all of this work? Who is doing all of this work? Rohit? I'm growing by 10. So 20 becomes now 30. Now, and then I'll, whatever the object that you gave me, I'll put it in 21st element. Did you understand?
You mean to say that like the array list itself supports the array to increase the size of the array list, right? Am I wrong or right?
Array list maintains, or array list under the hood holds the array exactly like this, and when you try to add, whenever it realizes that your current holding array, whatever the object that you put it, I'm putting directly into this array, Rohit, right? But when you give me the 11th element, I'll realize that, oh, my array is full. It's time to create the new array. I'm creating the new array and copying all the elements from the existing one to the new one. And I'll make my, this becomes my new array now. The new array is now size 20. Now you try to add 21st element. I'll do the same thing. So all of this work is done by the array list. Now let's talk. I thought it's pretty straightforward. We can talk.
I mean, yeah. My point is, I understand that array list takes care of increasing the size. That very well. I'm clear enough to get that point.
Okay.
But my point is, who takes the concept of increasing the size?
I'm saying array list, Rohit. That's exactly all of this is done by array list.
Oh, okay. So you mean to say array list only does that increase in the size itself?
Absolutely. See this one?
Okay.
Like how we have array list, you can write the array list for yourself, buddy. You don't have to take the Java's array list functionality. What I'm saying, take my concept. I told you what exactly is happening under the hood. You create your own data structure called Rohit's array list. And here you increase the size automatically. See that? Whenever you are full, whenever your backed up array is full, then grow it, keep growing. And again, every time you delete it, also you ask yourself, hey, how many objects? Currently my size is 30, and now how many are you deleting? You're deleting 15. Okay. Now you ask yourself, these 15 are empty. Hey, is it time to shrink my bag? Who is doing all of this job? Array list is doing it. Array list is maintaining this list, right? Now you removed 15 elements. Hey, isn't it time to shrink it? Yes. Why am I maintaining array with 30 size when there are only 15 elements? It is time to shrink. Let's say I shrink by 10 every single time. So 30 minus 10, or the closest 10. So closest 10 is 20, right? So I need my next array is 20. That's it. And then I'll copy all of these guys into the new one. Array list does this much behind the scenes. So that is why even though your array is fixed, but your data structure built on top of the array is dynamic.
Okay, I get that now.
So your array list data structure backed by arrays. It is arrays, but it is doing the array list is doing the ugly job of or heavy lifting of increasing, shrinking, growing, shrinking based on the needs. Understood?
Yeah.
But luckily we don't have to worry about it. But I wanted to tell you what exactly happens behind the scenes. Okay?
Yeah.
If you ever want to create a data structure like this, please go ahead and do it. Actually, luckily Java gave you, but Java, we can create it. My goal is always what happens under the hood, right? You can definitely create
Exactly.
a data structure like
I
that.
wanted to know that exactly because I know it's dynamic, but who takes care of making it dynamic? That is what my purpose is.
Exactly. Did you get it now?
Because, yeah, I got that. Now that's clearly because I was asked in some interview too regarding the why is the how is the concept of dynamic work behind the RLS? That is the whole point there now. I know the
Exactly.
RLS is dynamic. That is the point I want to know.
Yep.
Yeah.
Yep. No problem. This is one implementation. Later, I'll tell you when we talk about the linked list. That uses another data structure called linked list. The low-level data structure called linked list.
Okay.
Do you mean okay, Ravi?
Yes, I have one question.
Sure. Let me read these statements. That means it only increase according to what we define initially. No. It actually, every time it increases, if you really get into the details, right? Every time it increases, it maintains some factor based on the factor. Currently, let's say we agree that my factor is 0.75. Okay? Meaning, whatever the size is. Currently, let's say your size is 300 and somebody added 300 and first element. Okay? And I'll grow by 300 times 0.75. 300 by 0.75 is, am I decreasing there? No, is it 3 by 4, right? Yeah, I'm decreasing, right? Sorry, let's say my factor is 1.25. I'm sorry. Let's say my factor is 1.25. So I'm increasing by quarter. So if I initially have 10, I'm growing by quarter, right? Which is 12.5, but I'm going to the nearest one, so which is 13. Now 13 again times 1.25. When it's time to grow, I'll grow like that. So it actually grows by that factor.
Then we don't need to declare it, right, Venkat?
No. I'm sorry. We don't need to worry about it. In fact, you don't even have to know the fact that, I think you brought up a good point, Ravi. Let me make this clear to everybody. You don't even have to know the fact that behind the scenes, array list is maintaining whatever you gave by array. You don't even have to know that array list actually under the hood maintains an array. You don't have to know. As a user of it, you don't have to know. In fact, you can definitely change this factor, but there is a default factor that array list comes with it. So you don't have to worry about it. Are you getting it? It automatically does it. It automatically does. You don't have to do anything about it. You keep adding as if there is an infinite space. But every single time behind the scenes, array list does all of this. Now you go ahead.
Yeah, I got confused because when you told add 10, for example, if you're adding another 10 animals, right, it automatically goes, it takes 10. If you want to add 11, it takes 11. That's it. It goes like dynamically.
Oh, absolutely. But how it grows behind the scenes, I'm just telling you. That's all. Just for your knowledge, what exactly happens at, how does it do it? Hey, let's say tomorrow I want to create a data structure like that. How can I do it? I'm just talking about the core fundamentals here. Under the hood, what happens? That's all. You don't have to even know the fact that it's arrays. You get it?
Yeah, I got that. I got my answer, Venkat. Thank you.
Yep, no problem. Can we initialize? Jyoti, are you clear? You said a point. Whatever the code Venkat wrote is actually done by. Oh, yes, exactly. Whatever the code. Go ahead.
I was supposed to say to Rohit, but I typed to everyone.
Okay. Sorry. No. That
Because
definitely helps.
he was asking correct what kind of, I mean, who does it. So what I mean is whatever the code that you wrote, that is actually done by the array list. Because in the background.
Exactly. Whatever the code that I just wrote, the Rohit's error list, that is actually the implementation of error list.
Yeah.
Okay. In fact, I'll show you one of these days actually the real code also, JDK code. Probably we can do it. Let me. I'll get the code, the source code. I'll show you one of these days. I'll show you the source code also. Can we initialize it to 0? In fact, Deshkan, can you talk? Maybe now. I didn't understand that though.
When we add more objects, it will get increased, right, automatically?
No, we can't hear you. Sorry.
Hello?
Yeah.
No, that array list, so we can increase and we can decrease it.
Yes.
By adding, suppose if you take out all the objects, then it will, there will be,
That's a good point. That's a good point. That's an excellent point. So what he's asking is, let's say you have 30 animals. Now let's say you took out everything. Does it actually completely take out the array? No, it does not. It actually brings back to the original size. There is an initial capacity. It maintains an array with initially it creates an array with the initial capacity, right? It will always maintain that. At least there it will be there because you can come back and add it, right? So it will maintain that small, the minimalistic array behind the scenes, even though you took out everything. You get it? $100,000 richer. I can't hear. Okay. Venkat Krishna, did you have a point there, or we are clear on that? I didn't understand that.
Oh, no. I was just trying to say there's so much implementation like this being written behind under the hood, and they're writing so much in Java. So this is, I mean, the array list must have been implemented, I don't know, in which JDK, right? Couple years back.
No, it's a 15, 20, 15, what 15? Probably more. Yeah, it's more. 95?
95, they must have written this implementation. So
Yes.
it's pretty old, actually.
Exactly.
Old actually. That is really old.
Okay. It's a great question. It's a great question, but Java is so much ahead. They write so much behind the implementation. So,
But the point is, you don't happen to get it everywhere. I mean, this knowledge, this particular knowledge, like the concept behind the RL is how it works, you probably might not be getting the everywhere the same way as it has to be. There would be some tweaks into the
yeah. Right.
the explaining of the code. It will really make you confused. You know, I mean, you at the end you will confuse yourself. Really, how does the dynamic is working now? How being it's dynamic?
Yeah, it's changing. Yeah, that's right.
Point is that way, because I saw in interviews they data structures, if they go, they are asked that probably like how does this dynamic concept works on the array list.
Maybe if Sun is hiring you, somebody in California hiring you might ask you this question. It's possible. Right?
Yeah, I mean the one who array list. I mean data structures, yeah.
Well, they might have their own customized array list. You know, Google, you go, they might have their own exotic customized array list for their mobile application. Who knows? You know, they do all kind of.
Pretty much, yeah. Most of the a good number of companies do ask this on the array list when they go through our data structures. They generally do go for these questions.
Yep.
Data structures.
That's
right.
that is correct. Most of the tech companies they ask.
They might ask, yeah.
The reason is they want you to understand what happens under the hood, because there is so much abstraction over abstraction over abstraction. We lost the fundamentals. If you don't know what exactly happens behind the scenes, you will think that you'll just write your code. It works for regular thing, but if you have to write a customized data structure for yourself, then that's where the problem is. That's why it's a good idea to know it. So Yuri, what's your point, sir? Can you speak up? Technically, array list consists of 2 item elements and the counter that counts the elements. Yuri, you there? Okay, maybe he's having issues. So Madhavi, you were saying something earlier. You lost your question in the discussion, or you're still good? Okay. Madhavi.
Yeah, I have one question.
Yes, ask.
Yeah, if I have a 1 to 30 position for the array and I don't want the 17 position, then how it is working?
Okay, so you have 1 to 30th, okay, so and then, so that's a great question actually. So you have an array like this, and then let's say somebody removed animal at 17th position, okay. What happens in arrays? Tell me. How do you remove an element in an array? You just mark it as null. In that position, you mark it as null, and then you don't change you can't shrink the data structure. You can't shrink the array because there is an 18th element, then there is a 16th element. In that case, you cannot shrink it, Madhavi.
Okay.
You just mark your element, see, like this. Under the hood, what you do is a of 17 equal to null. So next time you removed it and I marked it as null, right? In arrays, there is no such thing called removing. You just mark your elements as null, right?
Okay.
Right?
Okay.
But this is again, we are talking about under the hood. Let me show you what exactly happens on the top level. We keep talking about under the hood, right? Let's talk about what exactly happens on the top level, right? So you have this class called array list. Okay. When you say array list, now I need to introduce something else here called array list. There is an less than and greater than symbol here, these angulars here, okay. When you define your array list is nothing but your bag, right? So when you define your bag, you need to say what kind of elements does this bag contain? Meaning, are you creating an array list to hold animals? Are you creating an array list to hold laptops? Are you creating an array list to hold all of my student names? So what is the type? Array list of what? You have to put that class name there. Let's say array list of string. We read it like this, array list of string, okay. I'll put my student names here, names equal to new array list, like that, okay. Array list of string, this is how we read it, array list of string. What it means is this array list bag takes only the string values, because you can't put in the same bag, you can't put a cow, you can't put a laptop, you can't put a student name, everything, right? You have to declare afferent that you have to know. In arrays also it's the same thing, right? You have to know. You will say like this in arrays, you'll say like this, string array. You are saying here that, hey, I need a bag to hold the strings. Here we say that I need a bag to hold the strings. Do we need to initialize it? We don't have to initialize it. Array list, you can definitely initialize it, but you can definitely create an empty bag, which behind the scenes your array list will create array with certain default size. You don't have to do it. You can definitely change it. You can provide the size here, but you don't have to provide it. Your array list will take care of it. Okay, array list of string names equal to new array list of strings. Now I'll say names dot add. See this one? Add. I'm adding. There is a method called add. I'm adding now. And now let me add. Do we have to initialize it? I think I answered your question. Okay.
Yes.
We'll just add all the students' names here in the alphabetical order. Okay. I'll just say nope. Okay. Names dot add Aruna Deshika. Okay. Like that. So this is how you keep adding the elements to the basket. You don't have to do, in the case of arrays, you have to do names of 0, no position, nothing. You don't have to know any of it. No position, nothing. You just keep adding. Under the hood, it will maintain the order. That's it. You know what is happening behind the scenes? It will put Anup in the first position. It will put Aruna in the second position. It will put Deshikan in the third position. And it will put Jyoti in the fourth position. It maintains the order because array list implements list interface, and list interface is supposed to be an ordered collection. Ordered collection meaning it maintains the order, and it maintains it. It takes the duplicates also. It takes the duplicates also. Let's say, I'll write one more time, Anup. It takes the duplicates. This is how you add to the array list. Okay, adding is good. How do you read from an array list? This is adding, right? Now, how do we read from array list? Well, this is how we read it. We can use this for each loop that I talked about earlier. Did I talk about this for each loop? I think I did, right? In the for each loop, when we talked about arrays, we talked about for each element inside this array list, okay, of the type string, right? And for each element in the bag names, see here, for each element in the, see, take from names, okay? Names is array list of strings, right? So for each element there, string name. So for each element, I'm holding into the variable called name. I'm holding each element or each string. First time Anup goes into this one. Second time Aruna goes into this one. Third time Deshikan. Fourth time Jyoti. Fifth time Anup. All of them are actually stored into this variable called name. And now I'll print it. I want to see, you just told me that array list maintains the order. I want to see if it really is maintaining the order. So I'll print the name. So this is how you add to the bag, and this is how you read from the bag. Just iterating through this one. You are iterating through this one. You are iterating through the bag and then printing every element. See, it's Anup, Aruna, Deshikan, Jyoti, Anup. It clearly told us two things. One, it maintains the order. In whatever the order, it's not like a random order. Whatever the order that I put it into the basket, it gave me in the same order. Number two, it allowed the duplicates. See here, Anup here, Anup here. Because list is supposed to accept the duplicates. Okay? This is one way to read it. There is another way to read it. There is another way to read it. What that one is? Your array list has a method called iterator. Now if you look at it, array list has all of these methods. Add, oh by the way, look at this one, add. We added in this order, right? But names.add if you want to do it, see? hey, can you add this particular name in this particular index? So you can be very specific and say that not maintaining in this order, 1, 2, 3, 4, 5 like this. No. Can you add this name into 15th position? You can do that too. See here? Anyways. See, you can remove. Okay. Now, if you want to remove, let's do this one. We printed this one, right? Now, let's remove it. Let's remove. Let's remove. Okay. And then now iterate through all the objects. Just to differentiate between that one and this one. I'll just now Anup, Aruna, Deshkan, Anup. Look at that. So this is how you remove an element from the collection. Okay. And now there is one more way to actually iterate through all the objects of the bag. Meaning read through all the objects of the bag. That one is, this names has a method called, this error list, it has a method called iterator. So get handle to that iterator. So iterator is an interface, iterator of string, ite or iterator. So what this iterator gives is, it gives you a kind of a marker, marker to point to all the objects in the bag. It gives you like a pointer, like a using pen. I will say 1, 2, 3 like this. It gives you the iterator. So as you loop through the iterator, it will keep pointing to the next element in the bag. It will keep pointing to the next element in the bag. Now, this iterator has a couple of methods, like a iterator dot has next. This has next will tell you. Let me explain how iterator works on the whiteboard too. Let's say this is bag, right? Item 1, item 2, item 3, item 4, item 5, etc. Right? Now, once you get the iterator, what happens with this iterator is you are actually pointing at it. It is giving you a pointer like this. So to start with, it points here. Okay? Now it points here. Now you are asking this iterator object. Iterator is also an object. It's an interface actually, right? So you're asking this iterator, hey, do you have more elements? Has next give you that. Has next method will tell you whether you have more elements to count. Yes, more elements to count, right? Now has next will tell you that, oh yes, I have more elements here. It gives you true in this case, right? Right? Now, then if it has more elements, then you're asking, hey, next. Okay? Now, this next method will give me the object. Now you're asking the pointer to move here, right? Now the pointer is not here. Pointer is at I1 and it gives you the object I1. It gives you the first item and you are here. So you grabbed your object here. Now, when you say has next again, yes, there are more elements. Again, the second time you ask it to next, right? Now this pointer is pointing to this guy and it is giving you that object and it is pointing to that. And it is keep pointing to this one, keep pointing. How do you make to the, how do you make this pointer keep pointing it to the next element? Well, this is where we'll use our fundamentals. We use our while loop. While, as long as, meaning, how do I read my while loop in plain simple English? As long as you have next element, while iterator dot has next, meaning as long as there are elements in it, okay, go into that and then read it. Next is actually, it is reading and now pointing to that element. So string name. Okay. Now, obviously, what element are we talking about? We are asking it to give us the element, right? Which is all of these names, which is strings, right? Now, we'll print it. That's it. Now, I want you to understand this. First time, let's look at so first time your pointer is here. Okay, when you did while it dot has next, you're asking, hey, do you have more elements? This is returning true. While it dot has next, meaning, hey, do it as long as this returns true, meaning do it as long as you have more items to read. Okay, first time it returns true. Now, when you say it dot next, so move your pointer to this, and then you give me that I1 back. You give me that item back. What is that item here? Anoop here. It gave me Anoop here. Now the pointer is pointing to this one. Now again you're asking, while it dot has next, hey, do you have one more item there? Oh yes, I have one more item to read. So this returns true. Now, okay, now go into the block and say it dot next. Now pointer moves to this one, right? And then it is returning this item 2. What is item 2 here? Aruna. Okay, now the pointer is pointing to this guy. Now go to the while loop. It dot has next. Hey, do you have one more item? Oh yes. Okay, and then go inside and then give me that dot next. So the pointer is pointing to this one, and then it gave us that item called Deshikan. Okay, and next time you again point to, and you get Jyoti, and then Anoop again. And now you're pointing here. Now you're asking, you are at one, the last element, this iterator is pointing to the last guy here and asking, hey, do you have has next? Do you have one more element? No, boss, I don't have. So this returning false here. So the moment this returns false, you will come out of the while loop, right? The while loop means as long as this is true, you go into this block. As long as you have elements into this, you're good. You go into it and read. This is also you can read it. There are 2 ways to read it. Okay. Any questions? Okay, let me show you another example, very similar example. So if you want to leave the 17th place as null, can you speak up?
Yes, Madhvi was asking if I want to leave a space, like leave an empty space in between. If we are creating 20 names, and if I want the 17th place to be empty, that was her question, right? So in case if I have 20 names and if I want the 17th place null, then I'll just leave it as such, right? Without entering any name.
Okay.
So it will automatically be null, right?
Okay, yeah. What we can do it is, actually, see here, this is the 0th position, first position, second position, third position, fourth position, right? Right? So what you do is,
Yeah.
okay, let's say third position. Let's remove the one at third. Let's remove the third one. And now we have Anoop, Aruna, Deshikan, and then Jyoti is gone, Anup is there. Right? This is how you do it, right?
Yeah, we remove it. But if we have created 20 and just I want to, okay, thanks. Yeah.
No, what I'm saying is, don't get confused with under the hood concepts with this one, Uma. So under the hood, what I'm saying here is that this is 0th position in array. This is stored in 0th position, first position, second position, third, fourth. Correct? Now I removed whoever is at the third index. Now the third index is null now.
Yeah.
Are you getting it? Now,
Yeah.
names dot get, I'm asking the third guy. Okay? So, string third student or student at position 3. Student at position 3. Okay? Let me print out. Student at position 3. Make sense? Oh, yes.
It'll be 2, right?
Oh, sorry, what did you say? Sorry, say that again.
Should we mention 2 or 3 errors?
No. This is 3.
2?
Actually, it starts from 0 itself. It starts from 0. Exactly. Let's go back to the fundamentals. I don't want to write anything on the background layer, so. Okay. Now, we have an array like this, right? Actually, more dynamism of the array list. So, when you created, you know at what point the underlying data structure is created? The moment you do this array list, no. Do you know at what point the underlying data structure is created? At this point. The moment you do new, the underlying data structure is created here. Okay? Okay. Now the beauty of the collection interfaces versus the old style arrays is there is no way of actually removing it. The only way you can remove it, so what I'm saying is this array list is backed by arrays. So these are positional, these are actually position based on 0. So 0, 1, 2, 3, 4, 5, 6, etc. like that, right? Now, there is a one student here, one student here, one student here, one student here. Now, what happens is, let's say this is a old style array. Okay? Let's say this is an old style array. Now, I want to remove a student at index 3. Okay, let's say there is a variable called names that is pointing to this array. So how do I remove a person that is positioned at index 3? How do I do that? Names of 3 equal to null. There is really no way for me to remove it. This space is empty. Right? Now let's say that names of 5, let's say I thought that in my initial class I thought that there would be 100 students, so I created an array list with 100 size. Okay, and then I removed I removed third position, I removed 95th position, I removed 86th position. So my students are scattered across this big array, but there are only 20 students in my class. Okay? There are only 20 students in my class, but the remaining 80 are blank. But unfortunately, these blanks are one here, one there, etc. In arrays, there is no way of really removing it. The moment you create an array with 100, your size is fixed. There is no way to shrink also. Okay? So what happens with now on contrary, what happens with array list is that, so this is one of the downsides of it. We'll talk about it when we talk about when should I use array list, when should I use a linked list. That's one of the most popular interview questions. We'll talk about that later. But here I'm saying that, hey, names dot remove 3. Now what I'm saying is, hey, can you please remove the person at position 3. Now we removed here. When we remove it, what exactly happens? This actually, I'll make it null, right? Right? Now, if I leave it, yeah, I can making it null in the case of arrays, right? If I leave it now, then is there any difference between my arrays and array list? Now, my array, I initially thought that size is 100 and I created it and I randomly removed one guy here, one guy here, one guy somewhere in the middle, and I removed 80 people. Still the back array is having array of that big size. Right? But array list is not that static. What happens is, the moment you remove this one, right? Okay, it will make an empty space here and move everyone like this. Now, whoever is at the 4th position comes to 3rd, whoever is in 5th comes to 4th, whoever is in 6th comes to 5th, etc. Now, there is no empty spaces at any point. So, you are automatically shrinking it. If there are, you created probably an array with 100 people, assuming that there are 100 students joining and then only 20 people, then all the 80 people, when you remove it, it shrinks automatically by adjusting them, and then always maintain that nice array that fits. And now, let me, since I'm anyway talking about it, let me talk about this one also. It's an excellent concept. One of the most popular interview questions as well. So it's backed by your 0, 1, 2 array, right? Okay. This is my array list. Now, I don't want to add in a sequential fashion. I want to add, I'll say names dot, okay, names dot add. Now I want to 5th position Rohit at index 5. Okay, but there is already one guy there. There is already one guy there. Ravi is already sitting here at this 5th position. But I want Rohit to be there. You know what happens? This is what happens. What happens is, if required, it will create a bigger array. If not, if it already has enough size, then what it does is, it will move everybody starting from 6th position. So 10th guy will go to 11th position, 9th guy will go to 10th, 8th guy will go to 9th, 7th guy will go to 8th, 6th guy will go to 7th, and then 5th guy will go to 6th. Now, complete 5th is vacant here, right? Are you understanding it? Who does behind the scenes all of this dirty work? Analyst or heavy lifting. Who is doing all of this?
Yes.
Analyst. So at the 5th position now, Ravi has moved already, right? This guy is already here because he was at 5th position. He's moved. Now it will make some space for Rohit, and then it will make this space empty for this guy, and then put Rohit there. Are you getting it? Now, let's say there is a array list with million positions. This is also one of the popular entry questions. There is a array list with million entries. Okay, I want to change my first element. I want to say that names dot add 0th position. I want to put myself or Venkat Krishna, the other Venkat Krishna, right? I want to put him here. So I have to move all 1 million minus 1, 999,909, etc. So I need to move all the objects to the right and make space and put this guy here. That is one of the most popular disadvantage of array list, because you're actually moving all of this. And also, I mean, copying is okay. You can definitely point the previous thing. I'm definitely copying every single time I grow it, right? Okay, that is also, you can definitely argue that's also one of the disadvantages. In fact, that is one of them. But the biggest one is, if you want to insert by index somewhere in the middle, or if you want to delete by index somewhere in the middle, all the elements on the right have to be moved one position up, and make some space for that, and now insert that guy there. Again, when you delete one guy, what happens is everybody, whichever the position that you are deleting from, all the people on the right side, like in queue, they have to move one square left. Okay, so every single time it happens, and this is one of the disadvantages. If you have this kind of requirement, linked list is better choice. We'll talk about the linked list in the next class, but linked list is better choice. And this is about array list. But the beauty of array list is that, okay, linked list has its own space. It has its own pros. It has its own cons. It has its own pros and cons. Okay. Now let me tell you the beauty of array list. I told you the disadvantages because we happen to talk about it. Now let me tell you the advantage. Again, you have the million elements here. Okay. I want to find out element at, I want to find out who is stored at 1000th position. I will quickly go, because it's backed by array, right? I'll just say of 1000, it will quickly give me, no matter what the size is, let the array list be having 10 elements or 10 billion elements, it acts in the same fast. This, in algorithm terms, we call it O of 1. O of 1. Meaning, it doesn't matter whether it has, oh, by the way, O of 1 are, this is actually in all the data structures, there is something called space complexity and time complexity, meaning how fast a data structure can act on an operation is typically measured with this big O notation. There is a notation called a big O. Some, fancy technical, all these techie companies like Apple, Microsoft, Amazon, Facebook, these companies ask these big questions, very low level questions. There is something called big O notation. So it tells you what is the data structure how fast it can act. So O of 1 meaning it doesn't matter how many elements you have it always acts O of 1, meaning it's the same whether it's 1 element or 10 billion elements. You can read an element at certain location with that fast from array list. That is the biggest advantage. And the downside is if you want to insert an element somewhere in between, or if you want to remove an element in between, the copying comes into picture. So that's a disadvantage of it. And now when we talk about linked list, I'll talk about what linked list is good for and what linked list is bad for. Make sense? Wonderful. And one example I wanted to say, these are actually really low level. If you look at my previous batch collections examples, I'm not sure whether I talked about it too. This big O notation and moving, copying. I don't know whether I don't remember exactly whether I talked about it or not. Since it came to my mind, I just happened to talk about it. These are more under the hood stuff. It's more fundamental data structures. Anyways, so you don't have to use it only for string. Let's say you're using animals, right? RLS demo 2 will go in just a few minutes. My point is, and if you understand, array list implements the list interface. And all this while I've been advocating on the left hand side you want to have, because it is very tempting for me to use the methods that are specific to array list. I don't want to really, okay? So always on the left hand side use list, okay? java.util.list. It's in all the data structures are in this, all the collection framework is in this package called java.util. Now, I'm talking about not list, but I'm talking about, let's say, list of dogs. Let's say list of animal. Okay. And now you can create several animals. Animal A1 equal to new animal. Okay, sorry, new, you can say new animal, new dog. Okay. Animal A2 equal to new new bird. Right. Okay, now you can just say names.add A1. You're adding all of these animals into a big bucket. That's what we're doing here. Right. And now you can go through all these animals into, now you want to send now let's say your animal feeder, all this while it's taking one animal, right? But now you can change your animal feeder to take a list of animals, and hey, you send me, you don't have to do it one animal at a time. Now I accept a big bag of animals too. No, you send me the whole bag, I will take care of feeding them. You know what I'm saying? Yes, are you getting it? See, in my animal feeder, I'm saying that public void, I'll say feed, but now you send me the list of animals. Send me the whole bunch of animals. I will feed for all of them. How do I feed? I want to go through each animal now, right? So for each loop, for each animal, inside animals, okay? Now see, I'll call any method on animal. Animal dot, let's say eat. I'll make them eat. See, now my animal feeder automated machine, I enhanced it to not just take one at a time. Now I'm taking the flock of animals or group of animals. You send me the whole group here. Okay? You send me the whole group here. And now here I'm coding to super type. I can definitely say that error list here. I can definitely say the error list here. But I'm forcing my users to pass only the error list. But there are other implementations. Why am I penalizing them? When I'm only doing the for each loop and then doing only animal.eat, I'm not doing any fancy stuff here. I'm not using any specific functionality that error list has any extra, right? So I should always code to super type. That's it. See this one? Now, animal feeder AF equal to new animal feeder. AF dot animal feeder. Oops. Oh, maybe I have not used. Okay. I have to use the not for polymorphism one. I have to use the one in interfaces package. AF dot. See, I'm doing list of animals. I'm sending the animals here. I think this one animals makes sense. So fantastic, fantastic, fantastic. Got it? So I sent 2 animals and 2 animals have been fed nicely. Now you create 1 million animals and send it to that animal feeder. It will do it nicely. So now animal feeder also has been enhanced to take, this is how you take it. Okay. Make sense? So I'm constructing, I created a big basket here and I'm creating all the animals and putting into the basket, and now I'm sending the basket to the animal feeder. Understand, in plain simple English word, I created a basket, I created animal, animal. I added animals to the basket, and now this is the basket, right? Now I'm passing the basket to the animal feeder, and now animal feeder is taking the basket. Inside the basket, it is looping through each animal in the basket, and it is making them eat. If I need to read this code in plain simple English, that is what I'm doing here. Make sense? Any questions? Okay. Now, let's go back to our javavenkat.com, and then let's look at more homework and then core Java collections. See this one? I want this to be done. Please create 2 separate packages for each object, one for JDK, one. Forget about this one. Forget about this one here. Create 1 package here. Actually, this is JDK 1.4. Where is that iterator? So this is how we used to do it pre 1.5, JDK 5. Before JDK 5, this was the only way we used to do it. And now, at that time, typecasting and all that stuff, don't worry about it. We are not doing it anymore. So create immutable and immutable classes for the below objects with the specified fields: laptop, car, television. And then now read from this list, okay, create immutable and mutable classes, create 3 different instances for each type and add them to the list. Okay, add them to the list. Laptop L1 equal to new laptop, laptop L2 equal to new laptop, laptop L3 equal to new laptop. Create 3 different laptops and then add them to the basket, which is a list. Now read from this list and print each attribute in console. Okay, like here printing, right? Here it is simple, but call every single method, animal dot eat, animal dot everything, move, like that. Okay, call every single method. So do it for more examples is my point here. That's all. Whatever we did just now, do it for more examples. Okay, and then once we talk about sets, we'll talk about the sets. We'll look at there. So this is the homework for tomorrow. And now, since I'm not going to be here on, we don't have a class on Tuesday and Thursday, this is what I want to do it. Go to this current batch. Okay. Can you please watch this video? String buffer API, string buffer, and then API. I talked about application programming interface and introduction to collections, kind of the same stuff that I talked over, and then more collections are here. Okay, can you please watch these 2 videos this Tuesday and Thursday and finish off? I want to see everybody on Saturday. So I want to meet with you guys on Saturday and Sunday, but Saturday at 10 a.m. I'll send an email also, but Saturday at 10 a.m. probably 2 hours. I want to meet, but before that, Tuesday this video. Tuesday is the first video, and then Thursday is this whole collections video, and do the examples on the collections. I wanted to reiterate at this point, collections are the most important topics in the entire core Java, period. Most interview questions are asked in collections. Okay, and once I come back, we finish off collections. You come with a lot of questions, and we'll do it together. Does it make sense? Is it fair? Thank you. Okay, that's all I have. Have a good day, everybody. Thank you.
Yeah. Could you please post today's video so
I
that we
will.
can watch
I will.
and
I will. I
it will
will.
be helpful to do the homework.
Yep. Give me about. It takes about 2 to 3 hours, so I'll do it immediately.
Sure. Thanks.
Okay. Thank you. Bye.
Thanks, Venkat.
Thank you.
Bye.
Bye.